Hello, everyone. Today, we will explore 50 physics theories that have changed the world, from micro to macro, redefining our understanding of the world. These theories are scientific breakthroughs, leading social evolution and redefining our understanding of the world. These theories are scientific breakthroughs and opportunities to lead social evolution. Here, we explore these physics theories and explore how they might shape our future.
Newtonian mechanics. Isaac Newton. Newton developed three laws of motion, which are basically known as Newton's three laws. Newtonian mechanics is a scientific theory that provides precise descriptions until high speed or microscopic phenomena occur. These are dealt with by relativity and quantum mechanics. It can accurately describe many everyday phenomena such as aircraft flight and building structures. Electromagnetic theory. James Clerk. Maxwell. He proposed four equations of electromagnetic theory that describe how charges, currents, and electromagnetic fields interact. It has wide applications in radio, television, and digital photography. Second law of thermodynamics, Rudolf Clausius, states that any closed system, entropy, always strives to reach a maximum value, and it is impossible for heat to move from a lower temperature to a higher temperature. With this theory, we can design and improve engines, air conditioners, and heating systems. Special theory of relativity, Albert Einstein. He proposed that the speed of light is constant no matter how the observer moves, which led to the theory of mass-energy equivalence and changed the understanding of time and space. Special relativity is used to correct the GPS positioning system. General relativity, Albert Einstein, describes gravity as the curvature of space and time caused by mass. Black holes, gravitational waves, etc. were predicted, now used in GPS positioning systems and aerospace navigation. Quantum mechanics, Max Planck, Werner Heisenberg, Erwin Schrödinger, describes the behavior of atomic and subatomic particles, used in the invention of lasers, semiconductors, and MRI in medical diagnosis. Uncertainty principle, Werner Heisenberg, describes the state of atomic and subatomic particles that have at least two properties that cannot be measured accurately at the same time. It is a fundamental principle in modern physics and cannot be directly applied to real life. Wave-particle duality, Louis de Broglie, proposed that atomic and subatomic particles have both wave and particle properties, opened a new chapter in quantum mechanics and deepened understanding of the properties of particles. Describing the principle of relativity, Galileo Galilei, stating that any physical law is invariant in all inertial systems, providing the theoretical basis for the theory of relativity. Heisenberg's quantum mechanics, Werner Heisenberg, proposed that in interacting systems, precisely defining the position of a particle will make its speed uncertain, which had a major impact on quantum computing and the study of the microscopic world. Ray optics theory, Isaac Newton, the belief that light is composed of particles, useful for describing and designing optical components such as lenses, telescopes, and microscopes. Pauli exclusion principle, Wolfgang Pauli, proposes that it is impossible for two electrons to occupy the same state, forming a theoretical basis for quantum statistical physics and chemical reactions. Hubble's law, Edwin Hubble, revealed that the universe is expanding and calculated the age of the universe through Hubble's law, which had a major impact on astronomy and cosmology. Schrödinger equation, Erwin Schrödinger, used to describe quantum mechanical systems, especially the behavior of electrons in atoms and molecules, and has a huge impact on quantum computing, atomic physics, etc. The Lagrangian form of dynamics, Joseph Louis Lagrange, used to describe the motion of particles or object systems under physical forces or complex interactions of particles, and has a huge impact on mechanical engineering and aerospace disciplines. Maxwell's equations, James Clerk Maxwell. Essentially the main content of electromagnetism, the four equations summarize the properties, processes, and relationships of electric and magnetic fields, which played a huge role in promoting the invention of radio broadcasting and radar. Electroweak unified theory, Abdus Salam, Sheldon Glashow, and Steven Weinberg, revealed the essential difference between the electromagnetic force and the weak nuclear force in the microscopic world, and provided a theoretical basis for the mass of neutrinos, which played an important role in promoting the development of particle physics. Effect. Bayes' law, Thomas Bayes, describes the probability of an event with a fixed probability occurring given other relevant evidence. It is widely used in the interpretation of statistical data and prediction models. International System of Units, International Federation of Laboratories, defines the 7 basic units in physics: second, meter, gram, ampere, Kelvin, mole, candela. It is generally accepted and used by scientists and engineers around the world. Strong interaction theory, quantum chromodynamics, Aslett Gross, David Politzer, Frank Wilczek, describes how quarks interact with each other through the exchange force of gluon particles effect. This theory played a huge role in the development of particle physics. Wind additional force theory, William Ferrel, describes the circulation of winds on the Earth, such as high and low pressure in the atmosphere, and is very important for meteorological prediction research. Aircraft lift theory, Daniel Bernoulli, describes the relationship between pressure and velocity caused by fluid flowing in pipes, used in the design and understanding of airplanes, cars, boats, and other fluid-moving objects. The theory of the Dyson sphere, Freeman J. Dyson, describes an ideal theory of space technology, a concentrated solar energy device around a planet used to power technological civilization, creating a new direction in science fiction and space exploration engineering. Schrödinger's cat experiment, Erwin Schrödinger, proving superposition of quantum states through a sealed object filled with poisonous gas. Although it has no direct application, it is integral to the interpretation of quantum mechanics. Hawking radiation theory. Stephen Hawking predicts that black holes can radiate energy through quantum effects. Although it has no practical applications, it greatly improves our understanding of gravity and quantum mechanics. Sentinel particle theory, Richard Feynman, John Wheeler, describes the situation where all particles and antiparticles are the same particle moving back and forth in space-time. Although not considered a modern physical theory, it has had a profound influence in theoretical physics and philosophy of science. An incomplete theory of black hole determinism, Roger Penrose, who proposed that singularities in black holes lead to incomplete predictions of general relativity, important for our understanding of gravity, black holes, and possibly new theories of physics. Electron spin theory, Samuel Goudsmit, George Uhlenbeck. Revealing the nature of interactions between atoms is a fundamental concept in modern physics and is used in a variety of quantum techniques, from MRI scanning to electron microscopy. Fermi probability statistics, Enrico Fermi, reveals the properties and behavior of fermions such as electrons and protons. It is widely used in condensed matter physics, that is, the physics of solids and liquids, and in magnetic-based technologies such as hard drives. French fries theory, Hervé this theory provides the correct temperature and time for French fries to make them crispy on the outside and soft on the inside. Although it sounds simple, it is an important theory for the French fries industry. Relativistic length contraction and time dilation, Thelbert, who added the ideas of time dilation and length contraction, which help us understand the relationship between speed and time, especially at speeds near the speed of light. It has practical applications in technologies like GPS and is important to our deeper understanding of time and speed. Newton's law of gravitation. Isaac Newton. This theory states that the gravitational force between objects is directly proportional to their masses and inversely proportional to the square of their distance. This theory is used to calculate the motion trajectories of the planets in the solar system and is an integral part of cosmology. Delayed choice quantum erase experiment, John Archibald Wheeler, revealing the paradoxical nature of quantum phenomena through a complex experimental design. Although it has no direct practical applications, it has had a significant impact on our worldview. Theory of relativity, Albert Einstein. He introduced a new way of thinking in theoretical physics, namely that space and time can be deformed. Since his theory was proposed in 1915, It has had a revolutionary impact on our understanding of our universe, from black holes to the expanding universe. Quantum state superposition theory, Niels Bohr, describes the phenomenon that microscopic particles can be in the superposition of multiple states, and their final state is not determined until observation. It is very important for understanding complex quantum systems. Röntgen radiation theory, Wilhelm Conrad Röntgen. It helps people understand medical imaging, material composition analysis, and other fields through a kind of electromagnetic radiation generated when electrons move inside a substance. Hydrogen energy level law, Niels Bohr, describes the different energy levels of electrons in atoms, which has a profound impact on understanding the spectrum of elements and the behavior of electrons. Maxwell's electromagnetic theory, James Clerk Maxwell, unified the three fields of electricity, magnetism, and optics to predict the existence of electromagnetic waves. Fermi-Dirac statistics, Enrico Fermi, Paul Dirac, describes the statistical behavior of bosons and fermions. Discussion of the path of robustness, Richard Feynman, describes another way of interpreting quantum mechanics as the sum of all possibilities for a particle to select from one point to another. The sum of all possibilities is selected from one point to another. Boltzmann's entropy theory, Ludwig Boltzmann, provides the definition of entropy, a measure of disorder, which plays a key role in thermodynamics and its understanding of the properties of matter. Hydrogen energy level law, Niels Bohr, describes the different energy levels of electrons in atoms, which has a profound impact on understanding the spectrum of elements and the behavior of electrons. Behavioral genetics theory, Nikolaus Steinbergen, Konrad Lorenz, Karl von Frisch, explains that animal behavior is shaped by the interaction of genetic and environmental factors. Random number generation theory, John von Neumann, proposed a method for generating random numbers, which is widely used in the fields of cryptography and statistics. Planar fractal theory, Benoit Mandelbrot, describes self-similar structures and multi-scale structures, and is widely used in computer graphics and the understanding of complex systems. Photosynthesis theory, Robert Hill. This theory explains the process of photosynthesis and how light energy is converted into chemical energy. Solar cell efficiency theory, William Shockley, Hans Kweisser, details how energy in sunlight is converted into electrical current, which is the foundation of modern solar cells. Principles of optical fiber communication, Charles Quen Cao. His theory changed telecommunications communications by using only one optical fiber for transmission. Thank you for watching. Please like and subscribe to Positivity Channel. See you next time.